Alrighty, guys. So we're gonna look at subtraction today, and some other larger rational problems too. But starting off with just subtraction. Nice thing with subtraction is it's not much different than what we did yesterday. So when it says something like, "What's the difference between this and this?" Difference means we need to subtract these two things. And just like adding, you have to have a common denominator. So right now, these denominators are not common. So what we're going to do is we're going to write them in factored form. We're going to figure out what we need to multiply to each side to create a common denominator, and we're going to do that. All right, so this one in factored form, we would want to use -8, +2. Okay, and then for this one, we'd want to use 4 and 2. +2. Perfect. All righty. So in terms of creating our common denominator here, they both have x plus 2s, that's good. But they have different terms here. So that means this one will need this x plus 4. So we go x plus 4 over x plus 4. And then this one will need this x minus 8. So x minus 8 over x minus 8. And so that's going to get us to having a common denominator. The next step is now, what do we do with this? Now, when I was doing the addition problems, I liked to just jump to kind of distributing and piling all these things together. The difference now is, with subtraction, is this whole quantity has to get subtracted. So I actually like to keep it as a separate problem for now. So let's go ahead and distribute. So we're going to get x squared. We're going to get an x. We're going to get a 4x. We're going to get a 4. Okay, and then from that, we're going to subtract these ones. So this is going to be an x squared minus 8x plus x and a minus 8. All right. Now, I do know that this is all going to be over, so I guess I'm going to keep it as one fraction. Sorry, I just did it as a quantity like this because I know all of this has to get subtracted. This is all over that common denominator that we created, the x plus 4, the x minus 8, the x plus 2. And it doesn't matter what order you write those three factors in. They're all interchangeable. It's multiplication. So at this point, I need to work out my common terms here, my like terms, and see what I'm left working with. So x squared minus x squared means this problem has no x squareds. Okay, cool. X plus 4x is 5x. Minus a -8, so that's going to add 8. So that's going to be 13x. Minus this 1 is going to take us back down to 12x. And then I have 4 minus a -8, so 4 plus 8 is 12. Okay, cool. This is all over same denominator still. Nothing changes down here until we get to the very end of the problem, if at all. And now we look at it and see if we can reduce things. So since this clearly has a GCF of 12, we get that out of there. And we see that this problem doesn't look like it has any common factors. Because we got x plus 1, x plus 4, x minus 8, x plus 2. Nothing on the top and bottom that looks like it could cancel out. And since nothing cancels out, that's going to be our simplified answer. And all we need to do now is include those restrictions. So since we never cancel anything, we can just use right here, -4, +8, -2. And there we go. So the takeaway here should be this isn't a ton different than just your standard adding problem. The only real part that's any different is right here. You have to make sure you subtract this as a quantity, not just one term. It's all of these parts that we get from their distributive property have to be subtracted. And that's really the only difference. Now, there's a couple down here. This one's kind of cool. This is one that has 3 fractions going on. So again, it's like the LCM problems we saw where we need to get 3 common denominators. So let's go ahead and see if we can figure this out. So it looks like looking at these, numerically, we could get them all to be 6s. And variables-wise, we'd like to get them all to be x's. Or sorry, x squareds. So we want to turn everything into a 6x squared. So that's going to be different things for different ones. This one is going to need to be multiplied by 2x over 2x. Okay, so that would give you 2x over 6x squared. Cool. This one just needs to get multiplied by x over x. So that's going to be x over 6x squared. And this one just needs to get multiplied by 6 over 6. So that'll be minus 6 over 6x squared. So this problem is sort of a simpler version because you don't actually have any polynomials going on here. You have monomials, single terms. And now we're basically good to go here. So this is going to be 2x plus x is 3x minus 6. So we have 3x minus 6 over 6x squared. And if we pull the 3 out, we can reduce some stuff. You see everything here is divisible by 3. So you could do one of two things. You could go GCF out of this and say this is 3 times x minus 2 over 6x squared. And now you can just reduce the 3 over 6 to 1/2, which is what I probably would do here. So that'd be x minus 2 over 2x squared. Technically, the 1 you don't have to write. So that would be our good simplified answer there. We need our restrictions. So x just can't be 0. That's our only issue here as far as that one goes. So that one's good. So just as a side note, if you do want to check a problem, because these are very checkable, they just take a little bit of time. You could take this, what you think your simplified answer is, and you could take the original problem, and if you put them both in a graphing calculator or Desmos or whatever and look to see if they're identical, that's how you know you've simplified it correctly. So like in my y equals, I put these in. Now, you do got to put in a lot of parentheses because you got like 1 over the 3x, you got 1 over the 6x, you got 1 over minus the 1 over the x squared. This one here, both parts in parentheses. But if you put that in, and I like to use the table, but the graph's fine too, you just want to look and see, are the tables identical? And my tables are identical, which tells me that I simplified this correctly. Just a little something to keep in mind that you can use for any of these style of problems, okay? All right, take a minute and see if you can do this one. This is just 2 problems. This is more like the one above. And let's see how it goes for you. All right, so this is actually a pretty good one. I like this one a lot. So I wrote the denominator factored here. And this one there's nothing to factor. It's already x plus 5. And I saw that all I needed to make the match was this one just needed x minus 5 over x minus 5. Because then I'd create the same denominator for both. So easy, I just had to change one of them. So I distributed my 2 and got 2x minus 10. And then I made sure I subtracted that as a quantity because I'm subtracting all of this from the 3x minus 5. From there, I combined my like terms. So 3x minus the 2x was x. Negative 5 minus a negative 10, which is plus 10, is a positive 5. And at this point, I was like, cool. I'm ready to cancel things out. So I wrote my restrictions down as negative 5 and 5. And I canceled those 2 out. Leaves me with just a 1 on top. Because remember, when things cancel, they're not really like canceling. They divide to be 1. So you're left with a 1 over the x minus 5. And so that's just, I don't know, it's a really clean one. I like how that problem works out. Definitely not too bad. All right. We are not going to do example 5 at all. So this page you can totally ignore. But example 6, we are going to do. And this is a good one. So this is a compound fraction. So a compound fraction is in the form of a fraction that has 1 or more fractions in the numerator and or the denominator. So in this idea, what we have is we need to add these 2 fractions together, but then we're also going to divide it by this fraction. So what we really need to do is think of this in terms of order of operations. We need to do this first. So we need to add those 2 things together. So let's just worry about that. Let's worry about what does that come out to be, and then we'll worry about dividing by this 1 over y when we get there. So in this case, if we want to add these 2 things, they are going to need common denominators. So I have 1 over x and I have 2 over x plus 1. And all I can do is multiply them by each other. They don't have anything in common as far as those factors go. So x plus 1 over x plus 1 here, x over x here. Okay, so what are we dealing with? We would have x plus 1 and 2x all over x times x plus 1. Combining like terms there, that's going to be a 3x plus 1 over x times x plus 1. And so that's going to be like good. That doesn't simplify. You can't factor. You can't do anything else with that to reduce anything. So now we basically have this. So this is my new numerator, is this thing I just got. And it still needs to get divided by 1 over y. So this is what I'm trying to figure out now. So what does this equal to? I'm going to work backwards here because I've written things weird on my paper. If you're dividing by a fraction, you can say the same thing as changing it to multiply by its reciprocal. So a better way to write this problem out, just to kind of think of how we've done things in the past, is here's my numerator. I have the 3x plus 1 times the x times x plus 1. I'm going to change it to multiplication, and I'm going to invert it. So I'm going to simply change it to that. which actually isn't bad at all because this is just a multiplication problem. So we just multiply across. So the 1 isn't going to do anything, but the y is just going to be multiplying it by y. So even though this problem looks weird, in terms of what we actually do to it, that's what it ends up being. Nothing crazy. Don't do more than that. Now we're going to see some tougher ones here in a second, but that's how that one's going to look. All right, let's go ahead and jump down to this one. So this is a more typical one, kind of just single variables, that kind of thing. So once again, we want to get it to single fractions. So like this fraction, cool. But down here, this quantity, we need to do this first. Anytime you have two things that need to get added or subtracted, that's got to happen right away. In this problem, you're going to need to do the top and do the bottom kind of on their own, and then worry about doing the division. So always think of these as kind of like big quantities. So in our case, we need to do this. We need to figure out what are we going to get from this. So we have x plus 1 over 3, and then 4 over x minus 1. So much like our last problem, we need a common denominator. So we're going to go x minus 1 on both parts here, and 3 times both parts here, and see how it works out. So we do need to distribute these. Remember how this works? So this is going to be a difference of squares. So we're going to get x squared minus 1, if you remember how that works. And this is going to be just plus 12. Okay. On the bottom, you get 3 times the x minus 1. And when we add this, it's just going to be x squared plus 11. So we have x squared plus 11 over 3 times x minus 1. Cool. So that's what this denominator is actually equal to. But I need to do this divided by that. So what I'm going to do, I'm going to take my 1 over x minus 1. I'm going to change to multiplication. I'm going to multiply by the reciprocal of this, because this is what's in my denominator. So now it's going to be 3 times x minus 1 over x squared plus 11. And a really cool thing happens here. Remember, with multiplication, you just think of it as one big bar, but you have x minus 1 on top and bottom. So we got some nice cancellation here to give us our final answer, which is just going to be just a 3 on top and x squared plus 11 on the bottom. And, we need to take a quick time out here to do our restrictions, even for the previous problem, my bad. So in this problem, there's some values that x cannot be. It's anything that's ever been in the denominator. So let's go back to the start. X can't be 1 because it was in a denominator at one point right here. X cannot be still 1, still 1. And then here, this would be imaginary because you need to only get negative out of here is for that to happen. So we don't have to worry about negative values. So it's just going to be just the 1 is our one value that x cannot be. Back to the previous problem, just real quick. In this one, our restrictions. If you remember, nothing canceled in this problem. So in this case, x just couldn't be 0 or negative 1. And then if we look through it, y can't be 0 also because it was in a denominator at one point. Same things there. Just checking through. Yeah, nothing else is ever in a denominator. So those would be our restrictions there. Okay. Take a moment and try this one out. So again, do each of these separately and then invert and multiply. See how it goes for it. Alrighty. So like I said, I took each of these parts and individually simplified them. So like this, I had to go x over x. So it became a 2x minus the 1 over the x. This one had x over x for this one to get it both parts over x. So I had x squared plus 2 over x. So those are my two parts. I need to take this one and multiply it by the reciprocal of that one, which is what I wrote down right here. Nice thing that happens here, x's do cancel, and we're just left with this over that. Last thing to address, what kind of restrictions do I have? X definitely can't be 0. It was in the denominator a bunch. And then it can't be, well, this one would have an imaginary value to get a negative there, so don't got to worry about that. And this part is never in the denominator, so don't have to worry about that. So just the 0. And there we go.